Okay, so in this section we're looking at graphs of sine and cosine. And so the first thing that we come to is kind of a recap of all the things that we've learned so far in the previous two sections regarding how the sine and cosine curves are transformed when the equation is changed. And so again, you've got both general forms for your equation. Just remember the absolute value of A, that's your amplitude, right? If we wanted to get the period, then it would be 2 pi divided by B. All right. Now, occasionally, I would say very rarely would you see it in terms of degrees, and if you do, it would be 360 divided by B. But almost always when you're dealing with the trig functions, you're going to see the graph expressed in radian terms. All right, so just something to keep in mind, but you may on very rare occasions see it expressed with degrees. Okay, so that is also there for you. Your phase shift, in other words, the horizontal shift, is obtained by doing C divided by B, and then your vertical shift is going to be D. All right, so this lesson here kind of ties everything that we learned in the previous two lessons together, and it approaches the transformations from a different perspective. See, in the previous two sections, we were given the equation, and we were asked to find these different characteristics. So now, the type of problem we're going to have is we're going to be given a graph, and based on the graph, we're going to be asked several different types of questions. Now, before we actually get into the problem, let's just take a look on a graph to kind of show you how changing these different things can manipulate the equation. And so right here I've got a standard sine function graph, and so you can see the 2 pi period and all that kind of stuff. And so here you can see the amplitude is 1 because the value of the A would be 1, and period 2 pi, there's no shift either vertically or horizontally, so there's no phase shift here. Okay, but let's see what happens if we just start to change some things. So like in looking at this one, let's say I were to in fact change the amplitude here. Let's say I wanted to change the amplitude on this thing. And so let's take a look at what happens when I turn this into a 2. Okay, so as you can see, the amplitude changes from 1 to 2. All right. Of course, if you add something to the end, it shifts it up by 1, vertical shift, or if I do this, it's down by 2. Right. So now when we come inside here, let's take a look at what happens. If I add, say, a 1 to this, all right, remember adding 1 directly inside of the parentheses when you've got the x wrapped up inside of a function, kind of like squared or square root, it's going to shift that function horizontally opposite the direction you might expect, right? And so typically we think of +1 to the right on the x-axis, but remember when it's wrapped up inside of this function and you add directly to the x, it shifts it actually the other way to the left. So as we take a look at, we see this 0, 0 point right here. That's at 0, 0 on the sine function. When I go x plus 1, it's going to shift it to the left 1 space. And then as we pull the point up, we can see that it is shifted over to the left by 1. All right. And then, of course, likewise, if I were to change that to a minus, it would shift it over to the right by 1 space. All right. And so that's kind of what your phase shift looks like. Now, let's say I were to take this off of here for the moment and just put like a 2 here. All right, so take a look at what happens there. So when you change that number, that is actually what changes the period, right? And remember, period is 2 pi divided by B. And so whatever you put here is going to be dividing that period. In other words, in this case, if it's greater than 1, it's going to be making that period shorter. And if it's between 0 and 1, it would be making that period longer. All right. So if I put 2 here, instead of the period being, instead of the period being 2 pi, like it was originally to make one full cycle. Now, take a look at the blue graph. The period is just pi. Why? Because of the fact that that value of b is 2, the period has now been cut in half, and we can see that reflected on the graph. Okay, here is something else I want to show you as well. If I make that negative, okay, wait a minute, let me address this first. Okay, so if I make the value of a negative, then it flips it, okay, over the x-axis. Reflection over the x-axis by making your a value negative. All right. If I make the b value negative, then it is going to flip it over the y-axis. Okay, reflection over the y-axis. All right. Now, where that becomes really significant is if I also have a value of c that's other than 0. That's either added or subtracted here. So like a while ago when I put -1 and it shifted it 1 to the right, all right, shifted that 1 to the right. If I were to make the value of b negative, okay, then remember that's going to reflect it over the y-axis when I do that. And so once that happens, it actually flips and goes 1 the other direction, right? So if I'm subtracting 1 from that x, that would cause a shift to the right by 1. But when I make the value of b negative, then that's going to reflect it back over the x-axis. So your shift actually changes from a shift to the right to a shift to the left, all right, when that value becomes negative. So that's one thing that we need to make sure that we keep in mind also as we're working these problems. Okay, that will take your shift and shift it from the right to the left, or vice versa, when you have that reflection through the y-axis. Now, when you change this, when you have the reflection through the x-axis, it doesn't affect the horizontal shift, you see. And so the only thing that would affect the horizontal shift would be making the value of b negative. All right, so just some things I wanted to make sure that we pointed out to give us a visual graph so that we can get a better understanding of actually what is happening when the values in the equation change. All right, so all those different characteristics we need to keep in mind as we're working the problems here. Okay, all right. So what have we got? We've got a graph to look at. There are several points that are listed out for us, which will help us to find certain characteristics. Also, to help us out, we've got the type of function here. We've got the value of c, and they also tell us whether the value of b is positive or negative. And that's going to aid us in writing the equation. All right, so remember, we've got the graph to look at to get information from, and we have some given information here about the function. Okay, so now let's go ahead and see what types of questions they're asking me for. The first one is going to be, what is the amplitude? Now, when they're asking me for the amplitude, remember, the amplitude is half the difference of the max and min, right? Or the height of half of the wave. Okay, so since this one is still pretty well centered on 0, 0, like there's no vertical shift on this particular one, then I can just count from here to here, and I can see what my amplitude is. And so in this case, from here to here, if this is 2, then this would be 3. If I wanted to verify that, I could see that my y values are going from -3 to 3. So that's a total of 6. And what's half of that? 3. So the amplitude is 3. Okay, so let's see if we can tell what the period should be here. This is something that we can also get by looking at the graph. And so if I wanted the period here, then I could take a look at this and I could say, all right, so from here to here is one full cycle, right? And so I can take a look at this and say, all right, so what's my period from here to here? One full cycle of the graph. To get that information, I would just need to subtract this x value from this x value. All right, so I'll subtract this first x coordinate, 7 pi over 3, minus the other x coordinate, pi over 3. Okay, so all I have to do is just look at the endpoints of a full cycle and subtract the x values, and then that would give me the period. So let's see what this turns out to be. So the denominators match, and so I can go 7 pi minus pi, that'd be 6 pi over 3, which divides out to 2 pi. All right, so 2 pi is the period. And so it turns out that the period is unaffected, right? Because it's typically 2 pi in the parent function for sine. And so what that really tells us is that my b value is going to be 1. It's not going to change the period, or negative 1, but it's going to be positive 1 because it tells us the b value is positive here. All right, so now if we wanted to verify that that period is correct, then we could go into use this equation, and as a matter of fact, we've already determined the value of b, but if we couldn't determine it because the period was changed, then in order to find the value of b, because we would need it to answer some of the subsequent questions and of course to write the equation, which is the last question, okay, the way that we would find the value of b is we would use this equation. So we've already counted here to here to see the period, right? So I know my period is 2 pi. I'll use this equation to solve for b. And so it would be the period, which is 2 pi, equals 2 pi over b. So we'll go 2 pi over b. And so if 2 pi equals 2 pi over b, then the b's got to be equal to 1. And we do know that it is positive 1, so we'll leave it at that. All right. So there's my value of b. We already were able to determine what that was, but if we couldn't, that's the equation we would use to get it. And so now we're ready to tackle this question. What is the phase shift? All right. So the phase shift, remember, is c divided by b. Okay. And so another piece of information that they give us about the function is the value of c. So all I need to do now is take this c and divide it by b. Well, the c is 5 pi over 6, and remember the b was 1, so we divide that by 1 and we get 5 pi over 6. Alright, so 5 pi over 6, that is my phase shift, 5 pi over 6. Okay, there's my phase shift. But I also need to describe which direction the shift is going. Okay, is it either going to the right or is it going to the left? And the two things that we need to know in order to figure that out is going to be the value of c, right, and the value of b. Those are the two things that we need to know. And so as we're looking at this, we know, okay, that the value of c is 5 pi over 6 and the b is positive. So since the b is positive, we don't have to worry about flipping over the y-axis and it changing from left to right or from right to left. All we need to do now is take our c and plug it into the equation, right? And so if that's minus 5 pi over 6, remember subtracting is going to send it to the right. And so what is the phase shift? It's 5 pi over 6 to the right. Okay. So again, if the c is positive, it's going to be to the right. If the c is negative, it's going to be shifted to the left. And if the b is negative, then you're going to reverse it. All right. So just something to keep in mind. You have to make sure that you get the descriptor right as to which direction the phase shift is occurring. And if you wanted to kind of look and verify that on the graph, 5 pi over 6 would be to the right, and 5 pi over 6 would be just a little bit below pi, right? 1 pi over 6 below pi. And if we take a look at that and see where that 0, 0 has shifted to, because remember, on the parent sine function, the 0, 0 would hit here, and we notice it is shifted 5 pi over 6 to the right. Okay, so because this would be equivalent to 4 pi over 6. So there's 5 pi over 6 and 6 pi over 6, which is pi. All right, so according to the graph, it is shifted the amount that we calculated for phase shift. So that's just one thing that you can double check to make sure that you're on the right track. Okay, so we're good there. What's the vertical shift? And so remember, the vertical shift is going to be how much we've shifted up and down. And so what we can do here is we can look at the difference between the high and the low, the max and the min, and say that the middle of the graph right here is at 0. And so since the middle of the graph is still at 0, then that means there is no vertical shift. Vertical shift was 0. It wasn't moved up or down because it would be off center. The center of the graph would no longer be on the x-axis if there was any sort of vertical shift. Okay, so we're confident to say that the vertical shift is 0 for that reason. And so the only thing that we have left to do actually is to write the equation. All right, so we've got y equals, remember A is the amplitude, and that it will come first. So it's going to be y equals to 3. They've told us it was the sine function. So 3 sine. Let's see, we'll open a set of parentheses. We know that the value of b is 1. And so all I have to do is just write our x. I don't have to write 1x. And then behind that, it's going to be minus the value of c, which we know is 5 pi over 6. 5 pi over 6. And again, there's no vertical shift, so we don't have to add or subtract anything to the end of our equation. This is the equation for this graph. All right, this is the equation for this graph. Okay, so there you go. Let's try one more of these. And so again, we have the graph listed out. We have some characteristics about the function, and we're going to be answering the same set of 5 questions. And so the first question is, what is the amplitude? What is the amplitude? Again, I'll need to look at the y values here and see it's from -3 to 1. And so the entire wave is 2, from max to min, the height of it is 2. And remember, the amplitude is half of that, so my amplitude would be 1. All right, so amplitude here is 1. Okay, so the next thing that we're looking for is the period. And so once again, to get the period, I can subtract the x values of one complete cycle, right? The endpoints of the x values of one complete cycle. So from here to here, that's one complete cycle of the function. So I'm going to go 9 pi minus pi. So 9 pi minus pi equals 8 pi. And guess what? That's your period, 8 pi. All right, so my period here is 8 pi. So the next thing that we want to look at is to see if we can calculate the phase shift. Now, to calculate the phase shift, remember we need the C and we need the B. All right, so in the last one, we were able to just ascertain from the equation what the value of B is. May not be quite so because we knew the period was 2 pi. Well, this time the period's 8 pi, so let's plug into our equation. So that means 8 pi, remember the period is equal to what? The period is equal to 2 pi over b. So I'm going to say 8 pi equals 2 pi over b, and then we can come up with our b. So from here, I'll probably just multiply b times both sides and divide both sides by 8 pi. Probably do that at the same time and come up with b equals to 2 pi divided by 8 pi. And so that simplifies to 1/4. So my b is going to be 1/4. And we do know that my b is negative. And so we may just want to make a note that my b is negative 1/4. Matter of fact, let's write that in. Negative 1/4. My b is negative 1/4. All right, so I'm already should be thinking, hey, we've got a reflection over the y-axis in this thing because of that value of b being negative. Okay. Now we have both things that we need to look at to calculate the phase shift, right? To look at the phase shift. And so to get my phase shift, remember what we're looking at. Phase shift, I want it to be C divided by B. I want it to be C divided by B. So we've got our C here. And so I know that my C is a negative value, and I know that my B is a negative value. But when we're going through and we're calculating phase shift, remember, we're going to get a distance, right, which is always expressed positive, and then we're going to put a descriptor after that. So we're not going to use positive or negative as the direction descriptor. We're going to write down a value, a positive value, and then we're going to describe it as moving that much to the left or right. Because remember, with distance, when you describe different distance, it's not really described like with a negative or a positive. The distance is always positive. But we're going to use that left or right to tell us which direction that it's moving. So what I'm getting at here is we can just kind of ignore the signs on this and then just divide the absolute values of the numbers and then see how far it's shifting, and then look at those values to determine, hey, is it shifting to the right or to the left? So really, I'm just going to divide the C by the B, the absolute values of those numbers. I'm not going to worry about the negatives. And this will work for us just fine every time. So I'm going to go pi over 4 divided by 1/4. So that's C divided by B. Like I said, we're not worried about signs at this point. And so that's going to be pi over 4 times the reciprocal. Flip it over. That would be 4 over 1, and that turns out to be pi. All right. So I know that my phase shift is pi. Now let's be concerned about the direction. Okay? So we know that my parentheses part of this is going to be a negative 1/4 x, right? And if I drop this minus pi over 4n for C, then it's going to be, remember, because there's already a minus from the equation, so it'd be a minus negative, and negative makes a positive. So I know when I drop that into the equation, it's going to be negative 1/4 x, and then what? A plus pi over 4. Okay, so let's think about what direction that would cause our phase shift to go. Okay, now, since this is plus, okay, typically we would say, okay, this is moving to the left. But remember, what does this cause? This causes a reflection through the x-axis. So instead of this moving to the left, this is going to actually reflect it, okay, back to the right. So my phase shift is going to be pi to the right. All right. So when you're calculating the number, you can just do absolute value. You're not really concerned with signs at that point. But then when you go to describe which direction it's going, we need to come back and determine, okay, so which direction is it going to be going, left or right, based on whether this is plus or minus this value, and whether or not we have a negative or positive here, negative indicating a reflection through the x-axis, which would change the direction of the shift, okay? Reflect that direction of the shift the other way, okay? So keep that in mind. What's the vertical shift here? All right, so let's take a look at what the vertical shift would be. And there is a vertical shift this time because the middle of the graph is not lined up with the axis anymore. And so we can tell what the middle of the graph should be. So from -1 to -3 is -2. So that -2 is the middle of the graph right there. And so since the middle of the graph is at -2, then obviously the vertical shift is 2 down. All right. So we can just use the points to determine what the vertical shift is. Now we're ready to write out the equation. So it's going to be y equals, we are told that we have a cosine function this time. So it's going to be cosine. And so, by the way, if we wanted to verify that it was cosine from the phase shift value that we had determined, that it's moving over pi to the right, okay, if we moved it back to where it was supposed to be, pi to the left, then that max right there would start off our function like it should be when you have cosine. Okay, so that's just to verify that it is cosine. Let's see, what else we got? We got and so, hold on a second, I hope that didn't stop recording. Just like my computer. It did not. Okay, very good. All right, and so we're ready to go in and write our equation. We know that our b is negative, right? A negative 1/4. So we're going to write negative. We can just go ahead and write that as x over 4 is probably how you would see it expressed. And or negative 1/4 x is fine as well. Either one would be correct. And then so from here, what have we got? So we've got our value of c is negative pi over 4, but remember it's minus negative, and negative makes a positive, so I'm going to make that a plus. Pi over 4. We will close it off, and down 2, minus 2 onto the end, and then we have the equation of the function. All right, so that's it. You're ready now for your quiz.